Hello student, I am Dr. K.Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing tough numericals based on electrochemistry. Now I will continue. I have discussed up to question number 465. Now I will continue further from question number 466. Keep pen and paper with you so that you can solve it easily. Now I am reading the question. Given a standard electrode potential Fe2 plus 2 electron, it gives Fe and its standard electrode potential is given minus 0.44 volt, and second reaction is given Fe3 plus 3 electron, it gives Fe. Its standard electrode potential is minus 0.036 volt. The standard electrode potential for Fe3 plus 1 electron, it gives Fe2 plus is, four choices are given, multiple choice. First, minus 0.476 volt, second minus 0.404 volt, third 0.404 volt, and fourth 0.772 volt. Again I am reading the question. Listen carefully. Given standard electrode potentials, first Fe2 plus 2 electron Fe, and its standard electrode potential is minus 0.44 volt. Second Fe3 plus 3 electron, product is Fe, and standard electrode potential is given. The standard electrode potential is minus 0.036 volt. You have to calculate the standard electrode potential for Fe3 plus 1 electron. It is giving Fe2 plus is. Four option is given. First option minus 0.476 volt. Second minus 0.404 volt. Third plus 0.404 volt, fourth plus 0.772 volt. Just to think how will you solve. After that I will give hint. At least you think how will you solve. Now I am giving you hint. You read the question, then it will be clear. In question, reduction potentials are given. A reduction potential of iron means in case of ferrous and in case of ferric. You have to actually Fe2 plus 2 electron, that is, it will give Fe means after reduction, and its value is given minus 0.44 volt, and second is Fe3 plus 3 electron, its value is given means Fe3 plus 3 electron, it will give Fe, and its reduction potential is minus 0.36 volt. Then you have to calculate a standard electrode potential for Fe3 plus 1 electron. It is giving ferrous Fe2 plus. That you have to calculate. Means for ferrous, reduction potential of ferrous is given, reduction potential of ferric is given, and you have to calculate reduction potential of ferric to ferrous. Ferric to ferrous. This is very tough. Just to think. Now I am giving you hint. Here you have to apply delta G is equal to minus NFE. That formula you have to use. Free energy, change in free energy is equal to minus NFE. That formula you have to use. Then here 2 times you have to use this formula. First time standard delta G or G1 you can write, that is equal to NF standard E. Then here for the reaction ferrous reduction reaction Fe2 plus 2 electron, it is giving Fe. For this reaction, what will be the free energy you have to calculate. Then delta G standard, that is equal to minus NF E standard. Here N is equal to 2. N is equal to 2. Then you put the value of all values given. Here N is equal to 2. F value you know, that is a 96,500 coulomb, and standard E value is given minus 0.44. Correct? Then don't put the F value. F you keep like this only. Then after solving means N is equal to 2. F you don't write, and E standard value is given minus 0.44. Then you will get 2 into minus 0.44. You will get 0.88 F Faraday minus NFE. Then N is equal to 2 and E is equal to again minus 0.44. Then minus plus. F value don't put. Okay. Then now we will get delta G value in terms of F. You will get 0.88 F. Same way you calculate, you can say delta G value for Fe3 plus 3 means ferric reduction reaction is given. For that, what is the standard delta G free energy? That is a G2 you can calculate. First one was G1. Now this we calculate G2. Same formula minus NF E standard. Here N is equal to 3. N is equal to 3 and E standard value is given minus 0.036. Then now you will get minus plus, you will get 0.108 F. You will get 0.108 F. Means for delta G1 value you are getting 0.88 F Faraday, and for delta G2, standard delta G2 value you got plus 0.108 F. Correct? For the two reaction, once for ferrous and ferric, for both free energy value you have calculated in terms of Faraday. Now according to the question, you have to calculate ferrous from the ferric to ferrous. From ferric to ferrous means ferric Fe3 plus 1 electron, it will convert to ferrous, that is Fe2 plus. Then for this reaction, what will be the value for delta G, that you have to calculate. Then how will you get it? Then just you subtract. Two equations are there. You have calculated delta G1 and delta G2. Then you have to get Ap3 plus 1 electron, that you will get ferrous. Then by the use of these two equations, two given equation, by the use of these two given equation, means ferrous equation, ferrous plus 2 electron, it is giving ferrous Ap, and second given equation is Ap3 plus, means ferric, ferrous and ferric. Both equation, by the use of given two equation, now you have to subtract, so that you will get Ap3 plus 1 electron, you will get Ap2 plus. Okay, by the use of given two equation, you will get Ap3 plus 1 electron is equal to ferrous. Then here how will you get? Then equation 2 minus equation 1, means two equations are given in the question. Then equation 2 means a ferrous, a ferric equation, and ferrous equation means equation, second equation minus first equation. Then you will get Ap plus 1 electron, that is the ferrous. Both equation you have to deduct. Then what is the purpose of deduction? You will get required equation, means which you have to calculate. You have to calculate Ap3 plus 1 electron, and then final equation will get Ap2 plus. Then for this reaction, to get this reaction, what will you do? Two equations are given. Then now from the second equation, just second minus 1, just you first equation first you reverse it and then deduct from the second. Okay, first equation reverse it and then deduct it from the second reaction. Then you will get Ap3 plus 1 electron, you will get Ap2 plus. Then given reduction potential value, first reaction, that also its sign will change. Then what value will get for the reaction, that is Ap3 plus 1 electron, you will get Ap2 plus. Then for this reaction, you will get delta G value, that is here only 1 electron is there, here n is equal to 1, and after the deduction of two given equation, you will get minus 0.772 F, you will get, correct? Equation 2 minus equation 1, but equation 1 you have to reverse it. Then given electrode potential value will be, their sign will change, and then you have to deduct. Then you will get delta G value, you will get minus 0.772, correct? Because second equation value was 0.88 value, 0.88 value. Then after that, after the deduction, you will get, because its value was minus 0.44, correct? You are deducting, remember. Then you will get minus 0.772 Faraday. In terms of Faraday, you will get delta G value for the required reaction. Means delta G value that is equal to minus NFE standard. For that you got means minus NFE standard that is equal to minus 0.772 F. Then now from this relation you can get very easily E value, standard E value, because both are in minus. Minus NFE standard you got value minus 0.772 F. Minus will be cancelled. Then E value will be how much? Then 0.772 divided by N. FF also will be cancelled. FF value also will be cancelled. Then E value will be simply 0.772 divided by N, and N is equal to 1 because only one electron is there. Then a standard E value you will get 0.772 volt. And say correct option will be option D. Option D. Correct. Then this D option means answer will be 0.772 volt. Now next question I will read. Actually this question was tough. This you have calculated by use of free energy relation. Okay, by use of free energy relation you have calculated, you have done calculation. Okay, you have calculated a value for standard E for the reaction Fe3 plus E, that is giving Fe2 plus. Okay, for this desired equations standard E potential you have calculated. Its value is 0.772 volt. Actually you have to deduct. Okay, you have to deduct. You can say these things, both equation you have to deduct so that you will get the desired equation. Okay, that you have, and when you will deduct, then sign will change. You remember, particularly for first reaction. If you will reverse it, then sign will also change. And after that just by the given value you will get this delta G value. You will get that value will get 0.772. correct. It is not after this what I told you, after doing that way easily you will get the result. Okay, now next question I am reading. Okay, next question is question number 467. Now the value of EH2O upon H2 means value of that is two electrodes are there. One electrode that is of H2O is converting to H2 at 1 atmospheric pressure. Means hydrogen gas concentration is, that is in the term of atmospheric pressure, 1 atm, and other electrode is, that is the platinum electrode, at 298 Kelvin would be. Question is simple but answer is difficult. Okay, the value of EH2O oblique H2 concentration is 1 atm oblique platinum. Okay, this is the I can say electrode potential value. Actually, you have to calculate the value of EH2O oblique H2. H2 concentration is 1 atm, means atmospheric pressure is given, vapor pressure, oblique platinum, correct, at 298 Kelvin would be first option minus 0.207, second minus 0.414 volt, third 0.207 volt, fourth 0.414 volt. This is also tough. Okay, just you think. Again, one more time, question I am reading. The value of electrode potential of electrode, given electrode is H2O oblique H2, means hydrogen gas electrode. Hydrogen gas, you can say pressure, which you can treat as a concentration, that is 1 atm at platinum electrode at 298 Kelvin would be first option minus 0.207, second minus 0.414 volt, second 0.207 volt, third 0.414 volt. Just to think, what will be the electrode potential of the given electrode? Given electrode is H2O oblique H2, correct? H2 pressure is 1 atm and electrode is platinum. Temperature is at 298 Kelvin. Just to think. Now I am telling you. Actually, this question is a tough. I told you here hydrogen ion concentration value. So it is given H electrode, the value of E electrode is H2O oblique H2 1 atm and electrode is platinum. Temperature is given at 298 Kelvin would be. Then here what you have to do, that is the Nast equation you have to apply. Then Nast equation is equal to E standard minus 0.0591 divided by N log after that pH, log pH formula you have to actually use. Okay, or you can write for the hydrogen gas electrode reaction, you know, that is hydrogen gas electrode reaction H plus plus 1 electron, you will get H, correct? H plus 1 electron, you are getting 1H2, correct? Means not 1H2, half H2, H plus 1 electron, you will get hydrogen gas half H2, and its pressure is given 1 atmospheric pressure. Then we know hydrogen ion concentration for these things, for you can say neutral water, that is the how much? That is 10 to the power minus 7 hydrogen ion concentration. Because hydrogen gas, it is a hydrogen gas, actually hydrogen gas is passing through the water. It is a standard hydrogen electrode. What is given, that is a standard hydrogen electrode. Then in this standard hydrogen electrode, hydrogen gas is passed through HCl, correct? That's why that I have given H2O, then H2O will ionized as H plus OH minus, and hydrogen gas you have passed. Then there at you can say at 298, at 220, 298 means what? 25 degree. At 25 degree, what will be the concentration of hydrogen ion? Then it will be 10 to the power minus 7. Then now this value we have to use in the equation. You also remember that distance you can here pH is equal to negative logarithm of hydrogen ion concentration. Don't forget, this concept will be utilized here. Or you can simply way also you can do, because H plus 1 electron, it is giving half H2. Then what will be the you can say reaction? Nast equation you have to write. Then product divided by reactant. Then product is hydrogen gas, half H2, and divided by hydrogen ion concentration. Then hydrogen ion concentration is 10 to the power minus 7. And hydrogen gas pressure is how much? 1. Then you will get in Nernst equation E is equal to E naught 0.0591 divided by 1, because N is equal to 1. In this case, log 1 divided by hydrogen ion concentration. Then 1 means for atmospheric pressure it is given. It is given for gas, that is the 1. And hydrogen ion concentration value is 10 to the power minus 7. Then now standard reduction potential of hydrogen electrode is 0. Standard reduction potential of hydrogen electrode is 0. Hence in the place of E naught, standard electrode potential you put 0. And then other things are given. 0.0591 divided by 1, because N is equal to 1 log, and hydrogen gas pressure is 1, that you are written 1, divided by 10 to the power minus 7. After solving, because it is 10 to the power minus 7, if it will go up, it will come plus 7, 10 to the power 7. Then now you will get 7 will come outside, then plus 7 minus 7, it will be minus only. Then this minus 7 into 0.0591. 7 into 0.0591, you will get minus 0.414 volt. Minus 0.414 volt. This is the final answer. Hence, correct option will be option B, minus 0.414 volt. So this question was tough. Okay, because here hydrogen ion concentration is not given, but at 298 Kelvin temperature is given. Then H2O ionizes. H2O ionizes. It gives H plus OH minus, Then that time at 25 degree, that is a neutral, water is neutral. At that neutral water, what is the concentration of hydrogen ion? pH is 7. pH if we will consider, then it is 7. And pH is equal to negative logarithm of hydrogen ion concentration. Don't forget. Or if you are knowing hydrogen ion concentration, then that is a 10 to the power minus 7. When pH is 7, then what will be the concentration of hydrogen ion? That is 10 to the power minus 7. Then hydrogen ion concentration you are knowing, and hydrogen gas pressure is given 1. Hence product divided by reactant, then 1 divided by 10 to the power minus 7. This value, 1 and hydrogen gas pressure value and hydrogen ion concentration value put in the Nernst equation. Then E standard E0 value is 0 for the reduction potential of standard hydrogen electrode. Hence after putting the value, Here n is equal to 1 because only one electron is using H plus plus 1 electron is giving half H2. Then after solving you will get minus 0.414 volt. This is tough numericals. Now next question I am reading. In this question is also all are very tough, not tough, very tough. Now next question 468. The equivalent conductance at infinite dilution of the salt Mx is 160.84 per ohm centimeter square per equivalent. If the transport number of metal ion M plus is 0.40, the ionic mobility of X minus ion means anion in centimeter square Simon per you can say centimeter square, you can say per Simon per volt each. You have to calculate actually ionic mobility of anion, that is the X minus, in centimeter square per Simon per volt is 4 option is given 3.9 into 10 to the power minus 5, second 6.7 into 10 to the power minus 4, third 2.5 into 10 to the power minus 3, fourth 1.0 into 10 to the power minus 3. Again I am reading one more time question. The equivalent conductance at infinite dilution of salt Mx, capital M, capital X, Mx is 160.84 per ohm centimeter square per equivalent. Means equivalent conductance value of the salt is given 160.84 per ohm centimeter square per equivalent. If the transport number of M plus ion is 0.40, means transport number of metal ion is given, you have to calculate ionic mobility of X minus means anion in centimeter square per Simon per volt. 4 option is given. What value I have given? Ionic mobility value is given. First option 3.9 into 10 to the power minus 5. Second option 6.7 into 10 to the power minus 4. Third option 2.5 into 10 to the power minus 3. Fourth option 1.0 into 10 to the power minus 3. Think how will you solve? After that I will give hint. Now I am giving you hint. You have to think fast. In exam time will be less. Now I am giving you hint. Here two formula you will use. First formula, that is the ionic conductance. Ionic conductance is equal to transport number of that ion into equivalent conductance of a strong electrolyte containing that ion. This formula you have to use. Okay. Again formula I am telling you. Ionic conductance of ion is equal to transport number of that ion into equivalent conductance of a strong electrolyte containing that ion. Then here transport number of ion you should know. Then how will you calculate transport number of that ion? Actually, you have to calculate ionic conductance. You have to conduct, not ionic mobility. You have to calculate ionic mobility. Equivalent conductance value is given, and transport number of metal ion is given. Transport number of metal ion is given. Then ionic conductance of ion you have to first calculate. Transport number, how will you calculate? Then you know that transport number of cation plus transport number of anion, that is equal to 1. This concept you should know. Transport number of cation divided by transport number of anion, that is equal to 1. Correct? Then here, if one value you are knowing, then means transport number of, suppose cation you are knowing, then anion you can calculate very easily. 1 minus you can say transport number of other ion, because sum is the 1. Sum of 2 ion is 1. Then if any one is given, other you can calculate. Hence transport number of that ion to which you want to calculate, that will be what? 1 minus 0.40, because 0.40 this metal ion value is given. Transport number of metal ion value is given 0.40. Then anion transport number of anion easily you can calculate 1 minus 0.40, because total sum of cation and anion transport number is 1. Then metal cation value is given. Then anion value you can calculate. How? Then 1 minus 0.40. Then anion transport number you have calculated. Then now you have to calculate ionic mobility of that anion. That's why you calculated for anion, because mobility of anion you have to calculate. Then now this first you calculated the these things, transport number of anion. Then now you can calculate ionic conductance of this anion, ionic conductance. Because transport number you are knowing now, then ionic conductance will be formula I told you. Transport number of anion in this case into equivalent conductance of a strong electrolyte. Its value is given 160.84. Then just to multiply both 1 minus 0.40 into 160.84, then you will get value 96.504. This is the ionic conductance value. You calculated ionic conductance value. Why you have calculated ionic conductance value? Because you wanted to calculate ionic mobility. Then for ionic mobility, what is the formula? Then formula is ionic conductance divided by 96,500. Means per coulomb. What is the ionic conductance? That is actually ionic mobility. This is the concept. Okay. Per coulomb, what is the ionic conductance? That is the ionic mobility. Then formula wise you can write ionic mobility is equal to ionic conductance divided by 96,500 coulomb. You are dividing it by 96,500 coulomb. Means per coulomb you wanted to calculate. Then now ionic conductance value you required. That's why you have calculated ionic conductance of ion. Then now you have calculated ionic conductance 96.504 you calculated. Then now you put the value in the formula. Then ionic conductance is equal to 96.504 divided by 96,500. Then after solving, after simplifying, you will get 10 to the power minus 3. 10 to the power minus 3. Then now here you can see option D is correct. In option D it is given 1.0 into 10 to the power minus 3. Hence option D is correct. This is also tough numericals. Okay. I think now it is 3 questions I have solved. Now I am stopping only here because okay, today only I am stopping only here. It will take more time. For three more questions I have to discuss. Next class I will discuss. Then this hard question, tough question will be finished. Okay, 3 questions are remaining. Next class I will discuss. Thank you.